Here's a very important question. Why do we care about least common multiple and greatest common factor, right? We just spent the last video going through learning how to find least common multiples and greatest common factors, and the question is, like, who cares? What's the point of looking at all these lists of numbers, okay? The important part about this, and it's used in other places, but one of the really important parts for us is going to be so that we can write equivalent fractions. And so let's talk about just what is an equivalent fraction, and then we're going to do stuff like making numbers larger, making numbers look larger or smaller, but actually be the equivalent fraction. So here are some equivalent fractions. Okay, they are numbers that they look different. Okay, they have different appearances, but they represent the same value. Okay, and so here's what we mean by that. If I were to say, 1/2, 2/4, 3/6, and 5/10, those are all equivalent fractions because they all represent 0.5, or they represent exactly 1/2 of the group, right? 2/4, if I have 2 out of 4 things, that's a half. If I have 3 out of 6 things, that's half the group. If I have 5 out of 10 things, that's half the group. So these all look different, right? If I were to look at 3/6 and 1/2, they don't have any numbers in common at all, but they represent the exact same thing, okay? The exact same situation, okay? So our goal is going to be able to take a number like 1/2 and turn it into 3/6, or vice versa. Like maybe I have 5/10 and I want to turn it back into a half, right? So using least common multiples and greatest common factors, we're going to be able to manipulate and change the way a fraction looks without changing what it represents, right? In this case, all these numbers represent a half, but they all look different, okay? And that's going to be important for when we get to things like adding and subtracting with fractions, okay? So let's take a look at an equivalent fraction. So if I want to change a fraction into an equivalent fraction, right, we are allowed to do that as long as we either multiply or divide the numerator and the denominator by the same number. So here's what I mean by that. The numerator is the top of the fraction, the denominator is the bottom of the fraction. I'm allowed to change the fraction. Like we'll look at this example and it'll all make sense. So if I take a look at this example here and say, okay, 3/4, I would really like the denominator of this fraction to not be a 4. I really want it to be a 12, right? So I'd like this to be a 12. Okay. Well, so I don't want to just say change the denominator to a 12 and I'm finished. I still need this new fraction with a 12 in the denominator. I still need it to mean the same thing as this, but just look different. Okay. So what I'm doing is I'm going to say, well, how did I turn 4 into 12 using multiplication or division? Well, it looks like I'd have to multiply that by 3. Okay, so 4 times 3, that gives me this new equivalent denominator 12. But this statement up here says I need to divide both the numerator and the denominator by that same factor, right? So in this case, I said times 3 in the denominator. I need to do a times 3 up here as well. So 3 times 3 gives me 9, okay? And so what that means is that 9/12 means the same thing as 3/4. And if you had a calculator handy and you went and did 3 divided by 4, you would get 0.75. If you did 9 divided by 12, your calculator would also give you 0.75. So the idea is that they represent the same portion of one whole, but they look different. One's got a 12 in the denominator, the other one's got a 4. So we can make numbers larger very simply by just multiplying by multiplying by any number that we want in order to change it. Okay. Sometimes we can use. Sometimes when we're looking at two fractions and we want them to have the same denominator, this is where this whole least common multiple thing is going to come in, right? So if I take a look at the numbers 5/6 and 7/18, I'm saying, oh, you know what? I really need for them to have the same denominator. And if you remember back to adding and subtracting fractions, which we're going to review next, okay, they must have the same denominator. If I look at 6 and 18 and say, okay, well, I need them to be equivalent fractions with the same denominator, what I'm going to do is I'm going to look at 6 and 18 and say, okay, well, what is the least common multiple of 6 and 18? Well, 6, 12, 18. Okay, and then if I make a list of the 18s, so here's a couple of them, right? But I'm going to stop right there because it looks like 18 shows up on both lists, right? So 18 is the least common multiple of my denominators. So here's what I'm going to do. I'm going to come down here. I'm going to say, let's make new fractions. We're going to make equivalent fractions. This one's got it. They're both going to have 18s in the denominator. Okay, this one and that one. Okay, well, if I'm saying, okay, how do I turn 18 into 18? Well, I'm not doing anything. I didn't change anything. So this one I'm going to leave alone. I'm not going to change anything. But I just turned 6 into an 18, and I did this by doing times 3. right? I multiplied 6 by 3 to get an 18. And so that means if I want the equivalent fraction, right, I need to multiply this 5 also by 3. 5 times 3 gives me 15. So it looks like 15 18ths and 7 18ths now have the same denominator, but I didn't change the value of 5 sixths. 15 18ths means the same thing. I just use equivalent fractions to make that change. Okay, so let's look at one more example of this, right? And then we're going to do what's called simplifying fractions, and then we're done. Okay, so in the second example, I'm going to say 3 and 5. Let's find a least common multiple of 3 and 5, which here we're calling it common denominator, but same thing. Okay, so I'm going to say the multiples of 3 are 3, 6, 9, 12, 15. And for 5, I'm going to say 5, 10, 15. There we go. There's my match. 15 is the least common multiple, which means for us it will be the least common denominator because 3 and 5 just happen to be denominators. So I'm going to say I would like both of these to be 15. All right. So now I'm going to come through and I'm going to say, well, how do I turn 3 into 15? Well, I'm going to do times 5. Okay. That means that if I want to turn 1 into something, I need to also multiply by 5. Whatever I multiply the numerator by, I have to multiply the denominator. So 1 times 5 gives me 5. Okay? So 5 fifteenths is an equivalent fraction to 1/3. Okay? I'm going to do the same thing over here. I'm going to turn 5 into 15. That's times 3. That means I need to do 2 times 3 as well. Okay? So 2 times 3 would give me a 6. Right? So 5 fifteenths and 6 fifteenths mean the exact same thing as 1/3 and 2/5, but now they have the same denominator, right? And again, we're going to use that in the next video when we start adding and subtracting fractions. But for right now, the only thing we're going to work on is making sure we can use equivalent fractions and least common multiples in order to make this change. Okay, so here's the last thing. We're going to talk about reducing fractions or simplifying fractions. Okay, typically when we present an answer in math, we want the answer to be in reduced form, okay, unless we have some other reason not to. Okay, when we're trying to reduce fractions, the only time we can reduce a fraction is if the numerator and the denominator have a common factor. Okay, so for example, and I'm going to show you kind of like not the wrong way, but the least efficient way of doing this. If I take 8 and 12, I'd say, oh, 8 and 12 both have a 2 in them. So if I divide both of these by 2, well, 8 divided by 2 is 4, 12 divided by 2 is 6. So what the claim is that by dividing both the numerator and the denominator by 2, I have 4/6, which is an equivalent fraction. That means 8/12 and 4/6 mean the same thing. Okay? However, 4/6 is not reduced, right? And the reason it's not reduced is because we did not use the greatest common factor of 8 and 12, right? So let's kind of look at 8 and 12 real quick. If I were to take 8 and 12 and break them down and make a list of all of the factors of 8, I would say, well, 1 and 8, 2 and 4, and that's really it, right? 12 only has those ones. If I were to do the same, 8 only has those 4. If I were to do the same thing for 12, I'd say, well, 1 and 12, okay, 2 and 6, 3 and 4, and that's it, right? So I want to say, what is the greatest common factor? What is the greatest number that these two lists have in common? And it looks like they both have a 4 in common, right? If you notice, they do have a 2 in common. That was the one that we tried to use, and then we're like, hold on a second, 4/6 isn't reduced, right? Well, that was because we picked a common factor, something that they shared, but not the greatest common factor. When we're reducing and we want to do it in one step and be finished, we always want to use the greatest common factor. So now that we know that it's 4, I'm going to go through this. I'm going to say, let's divide the numerator by 4, okay? Which again, if you want to show that, you can, okay? I'm sorry, I said 2 and then I said 4 and then I wrote 2. So let's fix that. So we're going to divide by 4. And I'm going to divide this by 4, okay, so it's numerator and denominator by the greatest common factor. And that's going to be 2. 12 divided by 4 is 3, okay. 2/3 is the reduced fraction, okay, the most reduced fraction for 8/12, because I use the greatest common factor, okay. So again, 63 over 90, they actually have a couple of numbers in common. For example, 3 is a common factor, but it is not the greatest common factor. In this case, the greatest common factor, if you make lists of 63 and 90, is going to be 9. If I divide this by 9 and divide this by 9, 63 divided by 9 is 7. 90 divided by 9 is 10. Okay, 7/10 is the most reduced fraction. Okay, 27 over 15. This is an improper fraction, but I can still say these have a 3 in common. Okay, so I'm going to say divided by 3. 27 divided by 3 is 9. And then 15 divided by 3 is 5. Okay? And as you get more comfortable doing this, you don't necessarily have to show this division here, but that's something nice to show just to remind yourself about what you're doing. Okay? In this case, that you're dividing the numerator and the denominator by the greatest common factor to get the most reduced fraction.